Greetings. Today I'd like to do a first look / overview of the new 12G SDI Embedder, De-Embedder to Dante from Sonifex. The part number on this, as you can see, is AVN-DIO10-12G. This is a successor to the AVN-DIO10, no hyphen 12G. That is still available. That is the 3G version, 3G SDI version of this. And one of the things we'll talk about is why you might want 12G versus 3G and save a little money by buying the 3G. This is a new product from Sonifex. It was announced a few months ago. I want to say something like April, May. I pre-ordered it as soon as it was listed on B&H, and it came in roughly 2 weeks ago, almost to the day. I have not used it yet on an actual gig, but I have done some testing with it, and I figured we could go over how it works. I mean, it's a new, they don't even have the manual online at the moment at the time I'm recording this. And so we can walk through how the menus work. We can do some input and output testing, including trying to get a sense for how much latency it adds and see who it's good for, right? So this is part of their AVN line. The D10 is Dante Module 10. They make a bunch of these that are all the exact same form factor. They also sell various mounting kits. So for example, they have a rack shelf. You could put 3 of these on a rack or mix and match with their other modules. So whether you need analog in or AES in or AES out or mic in, they have a bunch of them, right? They also have MADI converters. There's a whole suite of products. This is my first Sonifex product, but Sonifex has been around for quite a while. They make quality parts, and so I'm feeling pretty confident about this. Physically, the unit is metal. It's an aluminum box. On the front, there are a few LEDs. There is a fan. However, I will state that I have not been able to hear the fan unless I hold it literally right up to my ear. So that's good. I don't know if it'll ever ramp up enough that you can hear it, but it hasn't been an issue so far, and I've had it plugged in and running 24/7 since I got it. There is also a small reset button on the front, which hopefully you never have to use. On the back, let me turn on autofocus. On the back, as you can see, we have primary in and out, or primary and secondary for Dante, and then we have the SDI ports in and out. One thing that you will not see is a DC in anywhere on the device. It only takes power via PoE, and it will actually do redundant power on both ports. So if you have a redundant Dante network setup, you can, and switches that provide PoE, you can have PoE power on both ports, and then if one switch dies, you still stay alive, which is good. The drawback to not having physical DC in anywhere is that if you wanted to use this in a sound bag, because it is pretty light. I mean, you could easily, and it's smallish, so you could easily throw this in a sound bag, but you'd then have to power it. So you would need something that can do PoE injection. I don't have it in the bag right now. It must be in the other room. I have if you look at my video for the Voyage Audio Dante spatial mic, I talk about a small PoE injector that can be powered from your power distro in the bag. So who might this be for? Why would you need 12G? And why did I wait for a 12G SDI device before finally breaking down and buying one? This is, I would say, primarily targeted at, live events market, or if you are theater or something like that, because that's live as well, right? Live events, especially with smaller budgets, a lot of the time you've got the cameras all feeding in via SDI workflow into a vision switcher. The vision switcher is also acting as the audio mixer because it's taking the audio from the cameras. And then the vision switcher that outputs to display for the in-room display. It may also go to a recorder, etc. And as a sound person, you might need to do a couple of things. You might need to be providing playback to that vision switcher. So audio tracks and whatnot that they need played back. For that, you probably don't need 12G, because the way the vision switchers typically work is they will take any input and then internally they scale them up to whatever the output resolution is, or frame rate combination, right? So even if you are at an event where they're targeting a 4K output, which is becoming more common, it's not ubiquitous, but I imagine over the next couple of years, 4K for events is going to become the norm, and people will move away from 1080. And so when you're doing playback and you're sending audio from this into the vision switcher via an SDI, 3G will work just fine, because the vision switcher can take anything lower than the target output and will upscale internally. The issue is when you need to take audio out. So as I said, the vision switchers typically work by they scale everything to whatever the output resolution is. In this case, 4K, whether it's 30 or 4K 60. And then the only output they provide is that target resolution. They don't have outputs running at different rates. So if you need to capture, for example, the main program output to record for people to edit with in post, or maybe they're using their vision switcher can send you the ISOs of the individual cameras on different SDI channels, because keep in mind that SDI supports on 3G up to 16 audio channels. On 12G it actually goes up to 64 channels. And so to capture that output, you have to have a device like this that can take in 12G. Now, I am not a video events production company. I don't own a vision switcher. I will never own a vision switcher. I don't own much SDI, in fact. But what I do have is a red Komodo with a monitor. The Komodo uses SDI, and so we can use it to do some testing with, and also simulate what might be another use case for a device like this. So with the Komodo here, it can record internally, and obviously for red, that's how you get R3D, which is obviously the best format. But it's also sending SDI out to the monitor. And what you could do there is run this as an injector and send, for example, your audio into that external recorder so that the video on the external recorder has in effect a copy of whatever your mix out is, so that post has a really high quality copy of your mix already bundled with the video. Obviously they'll want to take your raw audio files later and match them up in post, but for dailies, for scratches, it might be helpful for them to have the real audio that you're recording instead of the junk audio coming from the camera. Now, again, as part of this demo, what I have hooked up here is I've got a BeachTech DXA Pre on the back of the Komodo. That is feeding into the audio input on the Komodo. And I have here a announcer's microphone that we can use for testing. And the setup is such that I will be recording both, or the Komodo is set to send both the internal scratch mics and the external mics out over SDI, so a total of 4 channels, and we'll be able to see and test that with this. So I said earlier we would do some latency tests. The other test that I was curious about with this device is, does it interfere with signaling? So in vision switcher world, sometimes the vision switchers can send over SDI in the horizontal blanking or the vertical blanking commands to cameras. Blackmagic does that, for example. I'm sure there are others. And technically, SDI audio is kind of this sits in the same area of an SDI frame. It's not exact, but for our purposes, it is. So I want to make sure that when this gets inserted in line, that it does not interfere with the signaling from the camera to wherever it's going. And in this case, we can test that by, does timecode still get through to the monitor? Does start record, stop record still get through? Does the file naming, so red clip name format, make it through to the Atomos still? We'll verify that. And then the other thing we will do is a little bit of test to figure out how much latency does this inject when you are feeding through it. Because in a live event, you don't want to be adding a ton of latency to your video feed, because people will notice that. We will also do some testing on the computer using RTL to loop through the device itself without the camera and whatnot, and then see what that impact, what kind of latency that gets. And then, like I said too, we will also look at how it is configured on the computer. The 3G version of this on the front had a row of dip switches, and a lot of its configuration was actually done through dip switches, although in later firmware updates they did give you the ability to set or override some of those dip switches from the web interface. With this device, there are no more, with the 12G version, there are no more dip switches. Instead, all of the configuration is done through the computer. So I'm going to switch and get this hooked up and do some tests with the Komodo and its monitor. Okay, this first test is going to be a baseline recording. Right now, SDI is going straight from the Komodo into the monitor. And when I talk into the announcer's mic, you should be able to see that as I speak, the monitor is showing the activity from the microphone coming out of the Coles announcer mic. I'm also going to be using the Betso slate, holding it so that the Komodo sees it, which means the monitor will see it, and then the Osmo Pocket 3 will also see it, and we can get us in post, we can count frame latencies between the different devices. All right, I'm going to reset for the next test. Okay, for this second test, I have the Komodo going out to the DIO and the DIO connecting to the monitor. I turn the monitor off so we can make sure that it has no remembrance of any of the data that it had received when it was connected directly to the Komodo. So we will turn the monitor back on. Right now, the DIO is set up to De-Embed Only, and it should be passing video through. Now, one thing with Atomos in the current firmware is it always defaults to its internal time code, which we don't want. So I'm going to switch this to source SDI, and as we can see, we get a 147, which is the same as what's being shown down here. And again, if I talk into the Coles microphone, you can see it bouncing around up here. And all 4 channels, so the 2 scratch audio and the 2 SDI channels, are coming from the Komodo into the DIO and then being sent over Dante to the Scorpio to be recorded. And so if I hit record on here, we see that the monitor also immediately shows record. And I'm going to talk into the Coles for a bit, and we will see what the de-embed latency on this is like versus the audio coming straight from the Axient. And then I'm going to do the clap test again. All right, I'm going to reset for the third test, where I am going to configure the DIO to do embedding of the Axient audio into the recorder. So what you'll see for the activity will be coming from my headset mic rather than from the camera. And also, when I hit stop on the camera, it stopped on the monitor. And the other thing is, where is the file? You can see that it has the red clip name that, again, came through SDI instead of the Atomos style clip naming. Okay, I have reconfigured the DIO to inject audio. I am talking into an Axient system. The Axient system is sending Dante straight to the DIO, as well as the same channel to the Scorpio. And then the DIO is set to embed that on channel 3, which replaces the first channel of the external mic hooked up to the Komodo. And again, I turned the monitor off so that we would be clean reset. Turn it back on. Update the monitor to go back to SDI again. I really wish it would remember that. And so now when I talk, you can see higher levels than when I was talking into the Coles, because the Axient's hotter than the Coles is a very quiet mic, even with a mic booster in line. But you've got activity on the monitor that when we do the recording and compare this in post, you'll be able to tell it's coming from my head-worn mic and not through the camera. And so I'm going to hit start record on the camera. And now I'm going to talk into the Coles a bit so that we can also have something to compare against when we look at it in Resolve later. And now I'm going to do the clap sync test again. All right. Now I'm going to switch things over to the computer, and in the magic of editing, you're going to transport there now. While we do a look at the computer for the Sonifex, what I want to show you is that I have got it set up now where I have an SDI cable looped from the input to the output, and that we will use that for the RTL testing as well as looking at the overall config in the web page. All right, so here we're looking at the home page of the DIO, or the 12 gig better De-Embedder. It advertises itself via zero config, so you can use its name plus the serial number .local and to find it rather than having to know what IP address it has on your network. One thing that is a little unfortunate is that it comes pre-configured with a static IP rather than DHCP. So you have to do the rigmarole of changing the IP address on a computer to be able to access it, to set it to DHCP, and then you'll access it normally then going forward. I really wish companies would just ship their stuff defaulted to DHCP. On the initial home page, you have basic info about the device, the control port, which is the IP for this, and then it also shows you the Dante information for the primary and secondary ports. I only have the primary port connected at this time. You can click on status and it'll show you what is coming in from the external on SDI, and it'll tell you what level it is and whether or not there are the audio groups present or not. Quickly, on the Systems tab, you can download firmware updates from their website. Currently, there are no new firmware updates, it's just the original release. And then you can also do a reboot or a factory reset. So System tab's kind of simple. The real magic happens on the Configuration tab. So on the Configuration tab under Network, you can rename the device, you can set a password for it, this is where you have to set it to dynamic instead of the default static. That's the static it defaults to. And then you can also, through the web interface, configure the Dante ports, which you can also do through Dante Controller. In order to get loopback to work, you have to enable SDI generator, because it will not output anything unless it thinks it's got an SDI signal to embed into. And if there's no SDI coming in, then it's just not going to send anything because it doesn't have anything to quote-unquote loop out. So you can turn the generator on. When you have it off, you can change what kind of signal it'll generate, what frame rate, pattern for it, for the video that it generates. But so if I say submit, and yes, it does take it a moment to process that. And then go back to information and status, you'll see that it does not think there's anything coming in. There's no audio or anything. So we'll go back to the generator, we'll turn it on. This auto gen feature says only turn the generator on when it doesn't see any signal coming in. But of course, if you're doing this loopback trick, when you turn AutoGen on, it sees a signal and then it turns itself off because it thinks it sees a signal even though the signal is from itself and therefore doesn't work. So I have AutoGen turned off. In your normal usage, you would probably want to have enable with AutoGen turned on. That way, if you actually have an SDI input, then it'll do the loop through with embed. And if you don't have an SDI input, then it'll generate its own. So on the Embedder tab, here is where you can set how the device embeds Dante onto the various channels of SDI. If it's turned off, if enable is turned off, it will not embed on that channel pair. You can only do it in pairs. There's no enabling for mono, unfortunately. Not that it really matters too much, but you are always going to overwrite 2 channels, even if you only needed to overwrite 1. This insert mode controls what happens when you turn on enable. So if we hit the question mark here, you can see insert. When you have insert disabled, like it defaults to, having this set to enable off means that instead of passing that channel through, it's just going to end up deleting it and sending blank audio for that channel pair. When you turn insert mode on, this means it'll overwrite 3 and 4, but it'll pass 1 and 2 through. When I was doing the testing with the Komodo, it was in the default of insert mode off, which means that it was deleting channels 1 and 2. So in the recordings, they were blank. There was no scratch audio when it was doing the embed because only channel 3 and 4 were turned on. You can also turn on test tones, which replace all the outputs with test tones. You can set it to a 96 kilohertz mode for SDI if you need to do that. And basically you have, because this is 12G, you have an effect 4 sets of 16 channels. If you were running at 3G only, like it's currently set here, then only the first set actually applies. For the De-Embedder, if we switch over to this, you still have the ability to select from the 4 different sets of 16. And then you can control whether each of these Dante groups de-embeds group 1 or group 5 or group 2 or group 6 or group 3 or group 7 or group 4 or group 8. When you're embedding, your only option is to send to groups 1 through 4. You cannot output on groups 5 through 8. Probably not a big deal. There's also the ability to bypass the sample rate conversion. So if your SDI stuff is clocked to the same clock source that your Dante stuff is clocked to, you can eliminate a little bit of latency by disabling SRC. Most of the time, however, that's not going to be the case, and you do not want to bypass the sample rate converter. That exists both on the embed side and on the de-embed side. So again, in the testing, de-embed, I had these turned off because there's no audio on groups 5 through 8 coming from the Komodo, or in this loopback test from the loopback. And all I had enabled on the embed side was to replace channels 3 and 4. If we look at it in Dante Controller, so we go into device info. Here you can see that I have got the input channels coming from this iMac because we're going to do some loop tests. Obviously, I had that configured differently when testing with the Komodo earlier. Transmit, when we send signal on here. So status, you can see this is based on the Brooklyn 3 chipset. Latency, I've got it currently set to 1 millisecond, and you can see that it has basically been pretty rock solid. Device config, you can do your normal rename, you can pick different sample rates. It supports all the different rates. You probably can't really take advantage of 192 or 176, although the sample rate converter will convert, SDI to whatever you have set the Dante side to. And then because it is Brooklyn, you can also change the latency. And in fact, actually, I will set that to 500 nanoseconds because that's what I do for most of the other stuff that's all connected to my main switches. Network config, it comes defaulting to Dante redundancy with DHCP for both addresses. And then again, Brooklyn supports all the modern Dante stuff, so AES67 and DDM and so forth. If you do identify device, it will blink all the LEDs on the front as well as the Ethernet jack LEDs on the rear. And then you can also set up multicast flows like any other Dante device. So in the routing, I have the MAC first 4 channels set to receive now from the DIO or the D10. And then likewise, I have the first 4 channels of the D10 set to receive from the MAC. And I have RTL here, which is configured to send out Dante, in Dante on ports 3. And if I do measure, we can see that we get 1,386 samples with a buffer of 512, but because this is an RME digiface, we can actually do 16 samples reliably, and you can see that it was a total of 394. And if I turn on loopback in total mix and do the measurement, you can see we get 73. And that's consistent. With loopback here, what's happening is RTL is sending to the RME over the USB port, and then the RME is just bringing it right back without actually going out to the network. But if we turn the loopback back off, when we do the test, you can see RTL sent out on channel 3, hardware output, i.e. the Dante channel 3, showed the blip as well, and then we also saw channel 3 on the input from Dante all blip at the same time. Right? Do that a couple of times. You can see they blip. Down here you have my mic out, and so that's when you see that when I'm talking. And I have it set up so that the Mac output is channels 1 and 2 are being recorded by the Scorpio as well, which is how, if I click on caster, you can hear the sounds, and you can see it going out here, and you should see it. Now you don't see it loop back on 1 and 2 though, because we don't have it enabled. If I click enable over here and then play this, now you see it loop back in on 1 and 2. Buzzer, that one lasts a little longer. You can see it is playing. I'm going to turn that back off. Okay, so that's a quick look at the device's config page and some round-trip latency tests where it had to go out over the network, go out the SDI, come back through the SDI, and we were seeing a difference of 322-ish or whatever samples. So pretty good. Gonna quit RTL. Now the next thing is I have here DaVinci Resolve. And I want to deep dive into the samples that we played earlier, right? So on the baseline, this one is pretty boring. You have the audio is recorded by the DJI, and you have the audio recorded by the Scorpio, and the DJI, even with voice isolation turned on, will have some noise in it because this room is very noisy. Okay. And what you can see there is that they are lined up pretty closely. The DJI is maybe 1 frame faster than the Scorpio, because the DJI is recording with its internal mics, and the Scorpio, the audio path to get to the Scorpio is my mic is connected to an AVN digital transmitter, body pack transmitter. That's going to an AVN digital. You can see the receiver in the rack here. And then from the receiver, it goes Dante to a Cedar Audio DNS8D that is also in the rack. You don't see the lights lit up because this went to sleep. The display went to sleep. And then from that, it goes to the Scorpio. So you've got 0.25 for the latency setting between the receiver and the Digifix, and the DNS8D, and then from the DNS8D to the Scorpio, it's 0.5. So you have about 3/4 of a millisecond in Dante latency there, and then you have the little, AVN is 2-ish milliseconds, I think they say. So that explains why you have a slight bit of difference between the DJI and the Scorpio. If we then switch over to decode only, so what we've got here is the DJI video, and then here is the video from the red, which when it starts just one frame before the Atomos starts, so there's a little bit of latency with the Atomos picking up that it started. I have done a little bit of rearrangement to overlay the Komodo and the Atomos video up here, and then also the main video is the view from the DJI. And right now I do not have any of the audio channels muted. So if we play this, what we've got here is this audio 3 in Resolve is my mic through the Scorpio. Audio 4 is the De-Embed of channel 3 from the Komodo, even though on the Scorpio it was channel 4. And this is quiet at the moment because I'm not speaking into the Cole announcer microphone at this point, so it's that microphone you have to really be right up to your face for it to pick you up. And then here you have the raw audio from the red, which again, because the Cole, I'm not speaking into it, is quite low. And then here is the audio from the Atomos. And this was all loaded into Resolve using insert, using timecode. So all of this is based on the timecodes from my Betso distribution to all the various devices. And as you'll see, things are not quite 100% lined up, but what we'll see is that actually the Scorpio audio and the Cole's De-Embed audio will line up very, very close. On here, so if we actually, the easiest way to do this is, no, that's a bit too far. Here we go. Here's a couple. All right, so here. So if I play this, what you're going to hear is a bit of a cacophony because you've got, here's the red. This is the Atomos, which I've noticed the Atomos consistently, the audio, even though the time code flows through, its audio will be a little bit ahead of where the red audio is. And then here is the real audio as recorded by the Scorpio, which you can see is about a frame ahead of, maybe a frame and a half ahead of the red itself, but it is 2 frames behind the Atomos. And if we scroll down and we look at the De-Embed coming from the Komodo and compare that with my mic from the going straight to the straight to the Scorpio, you can see that those basically line up. And we will see what the so you get that cacophony. But if I come up here and I will mute the Atomos track and we will see then it's a lot closer if I mute the red track as well and then play, and we will see now you can't really even hear any difference between the audio recorded by the Scorpio and the audio recorded by the Scorpio coming from the De-Embed on the Komodo. What the De-Embed latency on this is like. And then if we scroll forward a bit, here we see I'm about to clap the clapboard. And again, if we look at this, the Scorpio audio and the De-Embed audio, or sorry, the Axion audio and the De-Embed audio are almost perfectly lined up. The De-Embed is just a hair behind. It's maybe like half a frame behind. But as you can see, the red's internal audio is 2 frames behind, and the Atomos is 2 frames ahead. And like I say, that is consistent with what I have seen for audio on the Komodo feeding into the Atomos versus what I record to the Scorpio. And now if we go and we look at the embedding version, so in this, what has happened is the Scorpio, the red is recording, the Atomos is recording what it is getting from the DIO, because the DIO is embedding its audio. What the DIO is embedding is direct from the Axion as well. So again, the signal flow would be Axion body pack to the receiver, to the DNS8D, and then the DNS8D is going to the Scorpio, and it's going to the I keep saying DIO, it's D10. And then the D10 is doing SDI injection, which is going into the Atomos. And if we look at the audio down here, here's the Atomos track. The red track, again, the red track is the Coles, and right now it's going to be basically no audio because I'm not speaking into the Coles at this point. But if we look, the Atomos is again doing its audio is just slightly ahead of the Scorpio because I think the Atomos just has timecode timing bugs or whatever, that it's 2 frames ahead still, right? So if we move up, we can see 1, 2, yeah, roughly 2 frames. And then right now, the audio 4 is blank, because what audio 4 is that's the Scorpio still decoding from the Komodo. So there's no Coles talk into that at the moment, so it's blank. But the Atomos is getting the audio that is the same audio as Scorpio. It's just, as you can see, it's about 2 frames ahead. And now I'm going to talk into the Coles a bit so that we can also. And so now here, I've started to talk into the Coles, and you can see that again, the De-Embed audio basically lines up. I'm going to talk into the Coles a bit so that we can also have something to compare against in when we look at it in. But basically, because we get the same on, well, of course now now that it's doing the embed, it's weird. If we look at it at the start, or rather, sorry, this top one here, that's the red internal, that's the coals. And so if we look at the start of that and scroll down, you can see that it lines up pretty well with the de-embed of the coals. Here's the Scorpio. The Atomos is the 2 frames ahead of the Scorpio, and the red is 1 or 2 frames behind like before. So we'll turn these off. I'm going to talk into the coals a bit so that we can also, and it's just the where is one of the clap tests? So here we come with the clap test. So again, you can see that the Scorpio and the de-embed from the coals, because even though I'm not talking direct into the coals, because the clap is so loud, the coals picks it up. And then the Atomos, which again, keep in mind that the Atomos is actually getting the embed from the DNS. 8D is again, it's 2 frames ahead, but that's consistent with what we saw on the de-embed. And then the red is like maybe 1 frame behind. So all in all, I think what this says is you can use the Sonifex and it is not going to be a latency problem. De-embed lines up pretty much exactly, and knowing the finickies of the Atomos, I think the embed lines up more or less exactly. And then if we look at, well, unfortunately with the DJI, because of the angle, you can't see the frame number. Maybe you can see it a little bit there. So the DJI has captured 16, the Komodo has captured 16, and the Atomos has captured 16. So lined up via time code, they all match up in post as well for the video. At least, like I say, the audio, Atomos audio is always a little ahead. I don't know why. I don't ever use the Atomos audio usually, so not an issue. The video always lines up with the red video, so that's what's important for me in post. So that was a quick first look at the new AVN-DIO10-12G SDI Embedder De-Embedder for Dante from Sonifex. If you have any questions, please let me know in the comments down below. Thanks. Cheers.